Okay, so besides knowing the exact values of these special angles, what we really need to know, what we're going to use them for, is to draw the graphs of these functions. And then we're going to spend a chunk of time, if you look on your timeline, a large chunk of time worrying about the graphs of these things, right? And we're going to do transformations. And then you're going to look back at your first test and go, how did I get that wrong? This is so obvious what this transformation is, right? Because we're hitting transformations for like the third time. Okay? So at some point it sinks in and you realize that if x is replaced by 2x, well in this case it'll be like theta. If theta is replaced by 2 theta, then it's a horizontal stretch by a factor of 1/2. Okay. If theta is replaced by theta minus pi over 2, then it is a horizontal translation. Except this is trig, so we call it a phase shift. Pi over 2 units to the right. Okay. If y is replaced with 2y, then it's a vertical stretch by a factor of 1/2 about the x-axis, right? Like all the transformations just do exactly what they've always done. Okay. So transformation-wise, nothing new. All right, so we need to fill in the exact values so we can just work our way around. Sine theta is 0, 1/2, root 2 over 2, root 3 over 2, and 1. Then the values start going down. Root 3 over 2, root 2 over 2, 1/2, and they get to 0. And then they start going negative, because now we're in quadrant 3 where the sign is negative. And these are the special angles in order. And then, having reached the lowest, then we climb back up again. Back to 0. So that's the sine. Those are the values for sine. For cosine, we start at 1. Right, because we're at the far end. Remember, cosine is x, right? We're starting at the highest value of x, which is 1, and then we're going down till we hit 0, and then we're going to go negative. And all we're doing is counting again, right? So if I'm going down, it's it's positive root 3 over 2, root 2 over 2, 1/2, 0. Okay, now I'm moving into quadrant 2 where the x values are negative, so this will be negative 1/2, and we're moving out to negative 1, right? So we're going to do that just in order until we get to negative 1. And then from negative 1, we have to remain negative, and we're just going back the other way till we hit 0. And then we move back into quadrant 4, and we start moving out and getting back to 1 again. Okay. I moved the frame. Okay, and then tan is just, so tan is y over x, but if it's a unit circle, y is sine theta and x is cos theta, so tan is really just sine over cos. Okay, so sine over, so 0 over 1 is 0, and this is 1 over root 3, or root 3 over 3. This is 1, this is root 3, this is undif. This is negative root 3, this is negative 1, this is negative 1 over root 3, or negative root 3 over 3. 0 divided by negative 1 is 0. And then we get positive here, so that's 1 over root 3, or root 3 over 3. And this is 1, and this is root 3, and this is it's undefined. And negative root 3, negative 1 over root 3, or negative root 3 over 3. And 0. Okay, now I don't know if I can make that small enough to fit on a page. Almost. I don't know if you can see any of the values. So there's all the values. Right? Can you see them? Or I can make it bigger and we'll just do half at a time or something. Okay. And here are their decimal equivalents, right? Because we're going to graph this on a graph, then we need the decimals, right? I need to know, well, where are, I don't know what root 2 over 2 is, right? I got to work that out. What is it? Oh, it's 0.71. Okay. Scroll down to pi over 2. And all of this, the answers are all up there somewhere, right? Wherever there is. In the cloud, I guess, really? Schoology? It's got to be. All right, moving on. So let's graph these. Now, we have fractions, right? We have halves, thirds, quarters, and sixths. So what's the common denominator for a half, a third, a quarter, and a sixth? What number did 2, 3, 4, and 6 all go into? 12. So when we do graphs of these, so use the table of values, sketch, blah, 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 note the grid is scaled from, determine the angles between 0 and -2. Remember the terminal arms are rotated clockwise. So when we do this, here's the scale we're going to give you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? Because now you can graph the pi over 6, which will be 2 twelfths. Right? So now we got to think in terms of 12. So pi over 6 is 2 pi over 12, 2 twelfths. And we know that at pi over 6, it's a half. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to mark that. So I've got the 0.5, and then I better need a negative 0.5. 1, 2, 3, 4, 5. Okay, so I'm just putting a mark there so I know where a half is. Okay, so so 0 is 0 for sine theta. Pi over 6, which is 2 of these guys, is 0.5. Pi over 4, how many twelfths? 3 twelfths, right? So we just move over, we're at 2, we move over 1 more, and that's what, 0.71? So it's going to be a smidge above 0.7. What's next? So we've got pi over 4, then we've got pi over 3. Pi over 3 is how many twelfths? 4 of them, right? So we've got 2 twelfths, then 3 twelfths, then 4 twelfths. And that's where? 0.87? So just shy of 0.9. Okay, and then we've got pi over 2. How many twelfths is that? 6. So this was 4, so we're going to go 5, 6, and then up to 1. Okay? Keep going. So do the 0 to 2 pi. And I'm just going to pause this because really we're just graphing a graph. Okay, so once we have our points plotted, we're now going to join them with a smooth curve. Okay, and it's going to sort of peak there. So you're just going to come up through there, peak, fall down, fall to the minimum value, and come back up again. Okay. So there's y equals sine theta. Now that's from 0 to 2 pi. Now if we go the other way, so if you're going to negative pi over 6, that's coterminal with this angle here, right? With 11 pi over 6. So really, what we're doing here, from here, is just working our way like this. Okay? So I'm going to be lazy and say, well, that guy is going to be there, and that guy is going to be wherever negative 2 pi. 1, 2, 3, 4, 5, 6, 8, 9, 10, 12. There, and this guy's halfway, right? So that's 6. 1, 2, 3, 4, 5, 6. And this guy's halfway. 1, 2, 3, 4, 5, 6. And the other points are where they are, right? But we're just going to sketch this coming down and back up and down. Okay. Not the prettiest. I kind of missed the bottom there. I draw much better freehand ones than I do ones on a grid. I can freehand it better. Okay, so that's sine theta from negative 2 pi to 2 pi. Where are we here? Oh, yes. Determine the trig ratios. Remember the terminal arms are rotated clockwise. And now we're going to do cos theta. So same deal. With the cosine curve, So there's y equals cos theta, and I will pause this and allow you to graph it. So here's the sine curve, and the cos curve is the same curve, it's just shifted a little bit, right? I mean, if you look at the two of them, you just say, hey, if I moved you over to the right, you would be this curve, or if I moved you to the left, you would be this curve. So think of this curve. So they're called, the sine theta and cos theta are both called sinusoidal. Okay, so that type of curve is sinusoidal. So it's split into 4 parts, and I look at the 4 parts for sine. Starting in the middle, you go up to the top. Then you fall back to the middle, you go down to the bottom, and you come back to the middle, and that will be one complete cycle, right? You'll have covered all the possible values that you can, and then this thing's just going to repeat. Okay? So just think of these curves as split into 4 parts, right? From the middle to the max, back to the middle, down to the minimum, back to the middle. So the cos curve starts at a max, drops to the middle, goes down to a minimum, back to the middle, back to a max. So to sketch that out, this. Okay, so there's a cosine curve. And then the other one, just to kind of 1, 2, 3, 4, 5, 6, to cheat our way through this. Okay, because really I'm worried about 4 points, right? The middle, the maximum, the middle again, the minimum, and back to the middle again. Okay, and if you draw it smooth, then everything else will fall where it belongs, and then we know the values because we've got the unit circle, right? The unit circle for the other values. So here we do that. At this point, we're going to drop down here, and at this point, we're going to come back up there. So there. So there's your cosine curve. See, that was decent. Yeah, sure, the values are probably a bit off on that, right? But you know, as far as any of these values go, we can work them out, right? We know them. They're on the unit circle. They're exact values. And same deal, split into 4 parts, right? Oh, right, blue doesn't work. So starting at the max, go to the middle, to the minimum, back to the middle, back to the maximum, and then from there you're just going to drop back to the middle and so on, right? Or here you start at the middle here and get back to the middle. Here I'm starting at the middle and I'm going up and I'm ending at that same point, back at the middle, not here, because this is going down. Okay, so I could say, oh, well, you know, start down here. So if you start at the minimum, you go to the middle, up to the max, back to the middle, back down to the minimum, right? 4 parts. So, similarities and differences. I don't know why it's so big, because you can see them. Oh, okay, so. All right, we're supposed to answer the first question. So what are the similarities and differences? What's the same about them? Exact same shape. So they have the same shape. What else? How about, yeah?
Same scale.
Same scale. So it's the same range, right? They both go from -1 to +1. What about domain? So same domain and range. And if you think about it, as you go around the circle, you can take the sine or cosine of any angle, right? Because the circle is a continuous curve. So if you're anywhere on that curve, and all you can do is circle around that curve, right? Even if you go on 100 pi over 6. You just keep going around the curve. So it's continuous, right? So the domain is all real numbers, and the range, well, got a maximum of 1, you got a minimum of -1, right? Whether you're sine or cosine. What else? What's different? Are the intercepts the same?
No.
No. So the x and y intercepts are different. And really, what can we say about them? If I graphed sine theta, so if I took a transparency, stuck it over your sine theta graph, and then shifted it down to your cos theta graph, and moved it, what would happen? It would line up exactly, right? So they're really the same curve, they're just pi over 2 units apart, right? So it's a horizontal translation. So what am I going to say? The graphs are exactly the same, except one is a horizontal translation of the other by pi over 2 units. Okay, so the graphs, the graphs are exactly the same, right? They have the same values. You got that half, you got that root 2 over 2, you got that root 3 over 2. All the values are exactly the same. So the graphs are exactly the same. Except one is a translation of the other by pi over 2 units. Right. And you could say, if I take the sine curve and shift it pi over 2 units to the left, then I get the cos curve. If I take the cosine curve and shift it pi over 2 units to the right, then I get the sine curve. Okay, so same graphs, right? All this different. Same range, same domain, same shape. A function is said to be periodic if it repeats itself over regular intervals of its domain. Are these functions periodic? Yeah, they're going to keep repeating, right? The period is the length of the interval of the domain over which a graph repeats itself. So what's the period of sine theta or cos theta? 2 pi. Right? So in order to go through all of its values, right? So think of the sine function from 0 to the maximum, back to 0, down to the minimum, back to 0, is 2 pi. Sinusoidal data is periodic data whose graph can be represented by a wave pattern. Are they sinusoidal? I mean, it's named after sine, so yes, they are. The domain of both graphs is? Oh, so now we got to watch out because we start using theta, so it's a set of all theta such that theta belongs to the reals. So on quizzes and that, watch out for whether it says theta for the angle or it says x for the angle. You never know what we're going to throw in there. Okay, I don't think it's necessarily fair to dock you like a half a mark. Oh, we use theta, you used x, or vice versa. Ha ha, right? That's. But just watch for it. For both graphs, the maximum value is, and the minimum value is, and the range is. -1 is less than or equal to y, which is less than or equal to 1. Right? Or you could use interval notation. It'd be -1, comma 1 with square brackets all around. This would be -infinity to infinity with round brackets, and we'd put a d in front of one and r in front of the other to indicate talking domain here, talking range. The amplitude is, so has anybody heard of amplitude? Yeah, have you guys done physics, right? Some of you have done physics, okay? So you've heard of amplitude. It's half the vertical distance between the minimum and maximum points on the graph. Okay, so what's half the distance from here to here? From +1 to -1? 1, right? Because how far apart? +1 and -1 are 2 units apart. Amplitude is half that, so the amplitude is 1. I was thinking of half the distance to the goal line. It's a penalty within the 10-yard line. It's half the distance to goal. The median value is the value halfway between max and min. What's the middle of this graph? 0. So the median, right? It's like the thing they stick in the road so you can never turn when you want to. So I got to go 6 blocks out of my way so I can make a left turn because they had to put a big concrete thing in the middle of the road. That's the median, which is in the middle. The midline of a sine, and you can't pull a UE at certain lights, right? Well, depends who's around. But if you don't see them and they catch you, yeah. Midline of a sinusoidal graph is the horizontal, like though in California you can pull UEs on a lot of lights, right? It's like much more civilized as far as vehicles go.
You just can't.
And motorcycles can cut lanes in California too. Or lane split. You can go between the lanes of traffic. Can't do that here, not legally. The midline of sinusoidal graphs is the horizontal line drawn halfway between the maximum and the minimum. It's a line. A line has an equation. The equation of the midline is what?
0.
Y equals 0, right? So the median is the value in the middle. So the median is just a number, right? It's that value, it's 0. The midline is a line, and it has the equation y equals 0. These two are very closely related because they're really the same idea. Just one is a value, the other one is a line. The general expression for the theta intercepts of y equals sine theta. So look back at your sine theta graph. Where is it intercepting the theta axis? 0,
minus n pi.
and pi, and 2 pi, negative 1 pi, and negative 2 pi. So how are we going to say that?
Pi.
Yeah, so we usually say n pi. So the theta intercepts, the general expression for the theta intercepts is theta is equal to n pi, where n belongs to the integer. Okay, and this time, unlike coterminal, right, where we say that angle is not coterminal with itself, this does allow for 0 pi or just 0, right? Because n is an integer, it could be negative 2, negative 1, 0, 1, 2, etc. General expression for the theta intercepts of y equals cos theta. Okay, so look at cos theta. Where does it intercept? Okay, so let's do this. Where's the first theta intercept, the first positive theta intercept for cos?
0, like
1/2 pi, right? So pi over 2. And then how far is it between intercepts?
pi.
So it's pi over 2 plus n pi. So all we do is find the first one. Okay, it's a pi over 2. Where are the rest of them? And they're pi apart, right? And it makes sense if you just think about the unit circle, right? When is cosine equal to 0? When x is equal to 0. When is x equal to 0? Well, at pi over 2 and 3 pi over 2, right? 90 and 270 in degrees. So, and it's always going to be pi apart, right? Because it's up here, then it's down there, then it's back here. Which, if you're listening to this, makes no sense. What's the y-intercept of sine theta?
1.
The y-intercept.
0.
What's the y-intercept now? Pull out your answer. What's the y-intercept of cos theta? 1. So sine theta, y-intercept is 0, right? So it starts at the origin. I like to think of sine theta, it starts at the origin. It's at 0, 0. Cosine starts at the maximum, right? And then works its way down. What to be next? For the sinusoidal graph shown. Okay, here's how you do any of these problems, right? You can count. So what I like to do is say, okay, I'm going from 2 to 12. How far apart are 2 and 12? 10. What's in the middle? 5, so I'm going to go 7. So what I do is I sketch in the midline. And the equation of the midline is y equals 7. I'm doing that first, right? Because all I got to do is just count them and say, okay, they're 10. I'm just going up or down 5. There's the middle at 7. The amplitude is really the distance from the middle to the top or the middle to the bottom. So that's 5, right? We already actually kind of figured that out. And the period. So for the period, I have to go from a known point, like a minimum, back to another minimum. Okay, scale here is pi over 12. So I can just count these. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 pi over 12, but that's divisible by 4, so it's 2 pi over 3. Okay, that's by counting. Okay, we can also do, just take the distance between these guys, right? Which will be 3 pi over 4 minus pi over 12. Which is 9 pi minus pi over 12, just to get the common denominator, right? Which is 8 pi over 12, which is 2 pi over 3. Okay? So you can do it by calculation. If you know the scale, you can just count, right? It's like 1, 2, 3, 4, 5, 6, 7, 8. You can go from any point back to a point. It's got to be one cycle apart, right? So it's got to be, so this is starting at the top and ending at the top. 1, 2, 3, 4, 5, 6, 7, 8. Start at the middle and you're going down, and then you're going to get to here, which is the middle going down, right? That's one period apart. 1, 2, 3, 4, 5, 6, 7, 8. Start at the middle going up, and you can't do that because if you can identify half of a cycle, so half a cycle would be from here, wait a second, half a cycle would be from here to here, right? Like all I could say, I know that's half, 1, 2, 3, 4, which means the whole cycle must be 8. As long as you can see 1/4 of a cycle, you can get the period, right? So 1/4 would just be between here and here, right? 1, 2. That's a quarter, so the whole thing is 8, right? Multiplied by 4. Clean this up. It's messy. Okay, so start off, sketch in the midline, right? From the midline, you got the midline. Okay, you got the value of the median, which is 7. You get the amplitude, just count, right? There's amplitude is 5, so A is equal to 5. Okay, period. Okay, you gotta identify one period, right? One cycle. Okay, and that's from min to min, from max to max, from the midline going down to the midline going down, right? One cycle, one period. Identify that, and away we go. Okay, summary for graphs of sinusoidal. Cycle, part of the graph from any point to the next point where the graph starts repeating. So the cycle is one period, right? The length of the shortest interval that repeats. They're really almost synonymous, right? A period and a cycle. Periodic data, data that contains cycles or periods which repeat at regular intervals. Sinusoidal data, you've got a wave pattern going on. Median value, halfway between max and min. So it's the average, right? You're just averaging them together. What's halfway between two numbers? Their average. Okay, so we had 2 and 12. Right? So 2 plus 12, 2 plus 12 divided by 2 is 14, divided by 2 is 7, right? So the middle is at 7. Midline. The midline is just this value, but with like a y equals, right? Amplitude, half the distance. The distance between 2 and 12 is 12 minus 2, right? Which is 10. They're 10 apart, and the amplitude is half that distance, so 10 divided by 2, which is 5, right? Distance between max and min, blah, blah, blah. Okay, and then here's what it looks like. There's the period. This is, yeah, it's a little bit weird because usually we don't do numbers like this, like unless we're doing real life sinusoidal situations. And there's a lot of stuff that follows this periodic data. If you think of the motion of a piston inside of a car engine, right? It's going up and down, just like that. So if you graph its travel, it's going to be sinusoidal. Okay, a Ferris wheel, which is the obvious one, right? So you get on a Ferris wheel at the bottom, and it takes you up to the top, and it just repeats this, right? And it's periodic, and once it's moving at full speed, it just moves at that speed continuously, so it would sketch out a very nice sinusoidal graph. There's the midline, amplitude, distance from the midline to the max, or the midline to the min, the period, distance from 1. So this guy is at the middle going up, and it's going back to the middle going up. So it's got to be the same place. Okay, we can stop or we can go on. We're done.